Welcome to The Explainer. Today, we're going to dive into a powerful mental model that can seriously change how you see the world. And it all kicks off with what looks like a simple medical test.
All right, picture this. You go to the doctor. You're just getting some routine tests done, but then the results come back, and the news is a little concerning. So the test is for a disease that is super rare. It only affects 0.1% of the population. That's just one single person for every 1,000 people out there. So your starting belief, what we call a prior belief, that you actually have it should be, incredibly low.
Now, here's the thing. The test itself is incredibly accurate. It correctly flags 99% of people who genuinely have the disease. That's a really high success rate.
And it's also fantastic at giving healthy people the all clear. It's got only a 1% false positive rate. That means it only messes up and flags a healthy person 1% of the time.
So keeping all that in your head, the doctor gives you a call. You tested positive. And they remind you, hey, this test is 99% accurate.
So take a second. What does your gut tell you?
Most people, their intuition just screams 99%. I mean, it makes sense, right? The test is 99% accurate. But that's not even close. This is a classic example of where our brains just get completely tangled up by statistics.
Okay, so to unravel this puzzle, we've got to stop thinking in these confusing percentages. Let's just think about a real group of actual people instead. It makes the whole thing way more intuitive.
Are you ready for this? The actual real probability that you have the disease is only about 9%. I know, it sounds crazy low, right? But to see why, all we have to do is reframe the problem a little bit.
Let's just walk through it. Imagine a group of 1,000 people. Out of that group, only one person is actually sick. And our test, being 99% accurate, totally catches them. But what about the 999 healthy people? Well, that 1% false positive rate means about 10 of them are also going to get a positive result. So in the end, we have 11 people who tested positive, but only one of them is the real deal. Your result just means you're one of those 11 people.
You know, this kind of common sense logic actually has a formal name. It's called Bayes' theorem. And really, it's just a fancy way of saying it's a rule for how to properly update what you believe. That's your prior, when you get new information, so you can arrive at a smarter conclusion, your posterior belief.
Okay, but here's where it gets really interesting. This whole Bayesian thinking thing, it isn't a one-time calculation. It's a continuous process. You're always updating your beliefs as new information rolls in.
So you're sitting there with this 9% chance hanging over your head. You're obviously concerned, so you do the smart thing, you get a second opinion. You go to a totally different independent lab, and that test also comes back positive. So what happens now?
And boom, this is where you really see the power of this process. Your new starting point, your new prior, was that 9% chance. But when you add this powerful new piece of evidence, a second positive test, the probability that you're actually sick just skyrockets all the way to 91%. See, getting two independent tests to be wrong by coincidence is just incredibly unlikely.
And this amazing power of updating our beliefs isn't just for medical stuff. It's a critical tool for making smarter, more calculated choices in really high-stakes areas, like finance.
So let's say you're looking at this choice. You've got stock A, which is pretty risky, big potential payoff, but also a big potential loss. Then there's stock B, the safer bet. And based on what you know, you think there's about a 60% chance the market's going to be strong. But you don't just stop there. You call up a friend who's a real whiz at this stuff. Their recommendation is a new piece of evidence. Now notice their advice isn't perfect, but it's a really valuable signal we can use. This is where we update. Your friend is much more likely to say go for it in a good market. So if they do, that new evidence boosts your belief that it's a bull market, which suddenly makes the riskier stock A look like the much smarter play. But if they say stay away, that's a huge red flag, and now the safer stock B is the logical choice. You're using new data to recalculate the odds on the fly.
But here comes the big twist. Because while Bayes' theorem seems like some complex math formula, our brains are actually natural, intuitive Bayesian thinkers. We do this all the time without realizing it. We update our beliefs based on experience, and sometimes we're a little too good at it.
Let's make this personal. Think about a time you failed at something that really mattered. For example, you get rejected for a job you really wanted. That rejection? It's a powerful new piece of evidence for your brain.
Your brain takes that one data point and immediately goes to work. Your prior belief that you were qualified gets updated to a new posterior belief. maybe I'm not good enough for these kinds of roles.
And that right there, that is the trap. Because that new, updated belief directly changes your actions. You just stop applying for those big, ambitious jobs because you've concluded you're just going to fail again anyway. You've accidentally created a self-fulfilling prophecy, and now you'll never get the evidence to prove that belief wrong.
So, this is the crucial question, isn't it? How do we recognize these negative feedback loops that our own minds create? And more importantly, how do we break out of them?
Here's the key insight we almost always forget. In the medical test or the stock market, we're kind of passive observers, but in life we aren't. Our actions actively generate the very data points we use to update our beliefs about ourselves and what we're capable of.
Nelson Mandela said it perfectly. If you've never, ever seen something happen, your inner Bayesian brain might just decide the probability is 0. It can feel completely and utterly impossible, right up until that first time it's done.
So, the only real way to escape this trap is to become a scientist in your own life. You have to consciously choose to run experiments. You have to apply for that job, try that new skill, take that one risk, for the specific purpose of generating new data to challenge those old, limiting beliefs.
So the biggest takeaway from all this is simple. If you want to change a deep-seated belief about what you can or can't do, you can't just think your way out of it. You have to act your way out of it. You have to go out and run a new experiment. So the question for you is, what belief of yours needs a new experiment?